Okay, so we're going to have a look in this video at inequalities. So let's start with the symbols. Hopefully you're familiar with these. So we've got this symbol here, which you read as greater than. This symbol here means greater than or equal to. So the little line underneath that makes it look like an equals means it could include the number as well. Less than, and then less than or equal to. So those are our four main symbols that we use with inequalities. What we're going to start with in this video is looking at how to solve inequalities. So have an inequality that has an x in it and try and solve it. And we'll approach it very similarly to how we would with an equation, but there is one rule that we have to make sure that we don't break. So to try and show what that rule is, I'm just going to go through a couple of examples here. Let's imagine that we have the number 4, and we could say that that is greater than the number 3. Okay, so that's a true inequality statement. Now let's imagine doing different operations to both sides of that inequality and see which one of these rules ends up breaking that rule and stopping the inequality from being true anymore. So first of all, we could imagine, let's say, adding numbers to both sides. Let's say that I added 10 to the left-hand side and therefore added 10 to the right-hand side as well. That would give me 14 on the left-hand side and 13 on the right-hand side, and that's still true, that 14 is greater than 13. So the inequality symbol doesn't need to change, it's still true just like it was before. Let's go back to that 4 is greater than 3. So let's get rid of that now. And let's imagine taking a number away. So let's say we took away 10 from both sides this time around. So if I take away 10 from the left-hand side, I get minus 6. If I take away 10 from the right-hand side, I get minus 7. And minus 7 is greater than, minus 6 is greater than minus 7. So again, the inequality hasn't changed from what it was previously. Now, let's try maybe some multiplication. So addition and subtraction seems okay. What if we multiply? So let's say that we'll multiply both sides by 10 this time around. That would give me 40 on the left-hand side and 30 on the right-hand side, and that same symbol is still true. 40 is greater than 30. So far it seems that we can apply the majority of our operations to both sides of an equation and everything's okay, the inequality doesn't change. Let's try division. So dividing both sides by 10 would give me 0.4 on the left-hand side, 0.3 on the right-hand side, and that's still true. 0.4 is greater than 0.3. Now let's try one that's not going to work. So this time around, what I'm going to do is I'm going to multiply both sides by a number, which up till now has looked okay, but I'm going to multiply by a negative number. So I'm going to multiply both sides by negative 10 this time. So if we do that, we get negative 40. So 4 times negative 10 is negative 40. 3 times negative 10 is negative 30. And now the inequality has to switch because minus 40 is less than minus 30. So the inequality is no longer true if we keep it the same way around. So the basic rule of what we can do here is when we're trying to solve things with inequalities, we can treat them kind of like they're equations. We shouldn't write the equal sign, we should keep with whatever inequality sign we have, so whatever symbol we have, we should keep it the same, but we can still do the same things as normal. We can add, subtract, multiply and divide. The only time we have to be really careful is if we're multiplying or dividing by a negative number. As soon as we multiply or divide by a negative number, we must remember to switch the inequality around because it won't be true. It won't still keep on facing the same way as it did before. So that's summarized on these bullet points here, and you might want to just jot that down into your notes because that's the really key, essential bit of understanding that you need to know about solving inequalities. You can solve them just the same way as equations, except that you cannot multiply or divide by a negative number. If you do, then you have to switch the inequality symbol around. And what you might choose to do is actually move things around so that you never have to multiply or divide by a negative number. So I'm going to show you how to solve this one here as an example, and I'll show you 2 different possible ways that you could go about doing this that would maybe overcome this problem. So we've got 2 minus 3x is greater than 11. I'm going to treat it just like it was an equation and move things around on each side. So the first thing I'm going to do is subtract 2 from both sides. If I do that, that leaves me with a minus 3x on the left-hand side, and if I take away 2 from both sides, that means I've got a 9 on the right-hand side. So even though I'm treating this like an equation, notice that I'm still using the same greater than symbol that was in the question. I'm not going to change that at all. Now what do I do to both sides? I want to get the x by itself, so I need to divide both sides by minus 3. Now if I do that, I'm left with x by itself, and 9 divided by minus 3 is minus 3. 9 divided by minus 3 is minus 3. But I've just divided by a negative number. I've divided by negative 3, which means that I have to switch the inequality around. So the symbol that I had before, the greater than symbol, needs to switch to being a less than symbol. Let's try another way that you could approach this that would have avoided the problem entirely. So what I could do is, as soon as I see a negative and realize that I'm going to have to divide by a negative number, I could move that number to the other side of the inequality. So I'm going to do my other solution on the right hand side, and what I'll do is, the first thing I'll do is add 3x to both sides. So 2 is greater than 11 plus 3x. So I've spotted that it's a minus 3 in front of the x and thought, right, I need to move that to the other side. Then what are we going to do? We're going to take away 11 from both sides. So minus 9 is greater than 3x. And then we're going to divide by 3. That's okay. 3 is a positive number, so it's okay to divide by 3. That's not going to change the inequality. Minus 9 divided by 3 is minus 3. That is greater than x. And notice that the solution that I've got, I know they're facing other ways, but they're actually the same solution. If you say that x is less than minus 3, that's the same as saying that minus 3 is greater than x. They are equivalent statements. If we took one of them and reflected it, we'd end up with the other statement. So that's two possibilities for solving inequalities. One is, if you've got to divide by a negative number, remember that you have to switch the direction of the inequality, or avoid the issue entirely by moving the negative 3x over to the side so that you never end up dividing by a negative number. Here's one last example. Maybe pause the video for a second and have a go at trying to solve this one for yourself to see if you've got the right ideas, and then play the video afterwards to see if you've got the correct solution. Okay, so what I'm going to do with this one is I'm going to take away 6 from both sides, so minus 2 is less than minus 2x. Then what I'm going to do is divide both sides by minus 2. So minus 2 divided by minus 2 is 1. Because I've divided by a negative number, I've divided by negative 2, the inequality has to switch around like this. So I could say that either that 1 is greater than x, or I could say that x is less than 1, because again, they are equivalent statements to each other. Personally, I always prefer having the x on the left-hand side, so that's probably the way that I would leave my final answer, but either would be accepted as being valid solutions to that inequality.